Recording in progress.
Okay, students. So, group 17 revision. Group 17 elements, also known as halogen family. Also known as what? Halogen family. The elements present in this group are what? Fluorine, chlorine, okay, bromine, iodine, astatine, and livermorium. Okay, fluorine, bromine, iodine, and not livermorium. Tennessine, okay, TS. Yes. Yes. Fluorine's atomic number is what? 9. Chlorine's atomic number is 17. This is what? 35. This is what? What is the iodine's atomic number? 83. This is what? Not 83, 55. 50, you can add 18 to this one. So 53, that is 53. Iodine's atomic number is 53. Astatin's atomic number is 85. Tennyson's atomic number is 117. Okay. Yes. These are the elements present in group 17 elements. If you check their occurrence, fluorine available in the form of CaF2, fluorspar, and also 3 moles of Ca3PO4 taken twice. CaF2. This is what, my dears? Fluorapatite. Okay, fluorapatite. Next, if you check chlorine, 3 moles of Ca3PO4 taken twice. CaCl2. This is what? Fluorapatite. Chlorine also available in the form of NaCl. Chlorine also available in the form of NaCl and also KCl, MgCl2, 6H2O. Okay, KCl, MgCl2, 6H2O. And also fluorine available in the form of Na3Al fluorspar. Okay, fluorspar. Next, these are the forms of main sources of chlorine. Okay, bromine, if you check bromine, it is also available in the form of MgBr2, magnesium bromide. Okay. These are the general occurrence forms for halogen atoms. And then after, if you check their general electronic configuration, Ns to Np5 is the outermost electronic configuration. If you write their electronic configuration for fluorine, helium 2s2 2p5. For chlorine, neon 3s2 3p5. And also for bromine, this is argon 4s2 4p5, and also 3d10 is coming here. Okay. And next one, iodine, krypton 5s2 5p5 4d10. Okay. Xenon. The next one is astatine, xenon. Here it is 6s2 6p5 4f14 and also 5d10. And the last one is tennessine, if you check Rn, radon 7s2 7p5. Next 5f14 and 6d10. 10. See, the general outer electronic configuration for all these elements is ns2 np5 ns2 np5. The shell number would be varied. That's what we can say. This is ns2 np5. Okay. Here, if you check astatine, astatine is the radioactive element, naturally occurring radioactive element, and also tennessine is the man-made element. Tennessine is what? Man-made element. This is also radioactive element. And also, if you want to check their physical states, fluorine and chlorine, these two are gases. These two are what, my dears? Gases. And the next one is bromine. If you check Br2, bromine is in the form of liquid state, and also iodine in the form of solid state. This solid is it is the volatile solid. This is the volatile solid. This is what? Volatile solid. So from top to bottom, condensation of molecules would be increased. That's what gaseous state becomes liquid, and then after solid. And the atomicity of these halogens, if you check atomicity of these halogens, all are diatomic molecules. All are in diatomic molecules. Nothing but all are in. That means simple formula is X2 form. This is X2 means maybe fluorine F2, F2, Cl, Br2, Cl2, and I2. Okay, these are the this is the atomicity of halogen family. Nothing but all the halogens are exist in diatomic state. Okay, next one. Okay. Yes. Next one is, if you check colored property, fluorine available, fluorine can show yellow color. All are going to absorb radiation in visible region. All are going to absorb radiation in visible region. So Cl2 is in the form of greenish yellow. Greenish yellow. Okay, next. Please 1 minute, students. Okay. The next one is fluorine shows yellow color and chlorine shows greenish yellow color, and also bromine. Bromine is in which color? Red color. Red in color. I2 is in which color? Violet color. Violet color. Listen here, fluorine needs more energy to show yellow color. Why? Actually, how these colors are going to be appear for each and individual element? The reason is here, That means the electrons present in these atoms are going to be excited and de-excited. The equator transitions are going to be happen. That's what at that time the electrons are going to be take some energy. So that energy, most of the cases for halogens, energy absorbed in the visible region only. Fluorine takes more energy to absorb and to excite. Fluorine takes more energy to excite, more energy to excite. Why? Because it is the small size. That is the reason it shows, it takes large energy. Okay. Yes. Next one, iodine takes less energy. Iodine takes less energy because it is having large size. So excitation of electron going to be higher level, that is already in the iodine. That's what it takes less energy. Okay, it takes less energy. Okay, yes. Next one. Next one, if you check bonding and valency. Bonding and valency, if you go to valency, all these elements are general valency are nothing but minimum valency is 1, maximum valency is 7. Minimum valency for all these elements is 1 and maximum valency for all these elements is 7. Okay. Yes. So fluorine can always show 1 valency. For fluorine, always 1 is the valency. For remaining elements, if you check remaining elements, they can able to show for remaining elements, chlorine, bromine, iodine, they can show 1, 3, 5, 7. And also chlorine and bromine can show 4 and 6 also. Okay, this is the general valency. So bonding depends upon this valency. Bonding depends upon this valency. One halogen bonded with another halogen by a single covalent bond. This covalent bond formed by combination of 2 electrons from 2 halogen atoms. If possible, write this one. I'm going to next page. Okay, I'm going to next page. Yes, yes. Next one. Oxidation states. Next one, if you check oxidation states. Oxidation states. Fluorine can show oxidation states nothing but here -1 to +7 oxidation states. Fluorine can show only -1 oxidation state for fluorine, only -1 oxidation state for fluorine. And next, -1 and +1 for remaining elements. Chlorine, bromine, iodine. Okay, acetylene we are not discussing here because it is what? It is radioactive element. Okay, so we are not discussing about this. Remaining +3, +5, +7 shown by chlorine, bromine, and iodine. Okay. Next one is +4 and +6 shown by chlorine and bromine. Only in their oxy acids, oxides and oxy acids, they can show oxide in their oxides and oxy acids. Remember this one, oxides and oxy acids. Oxy acids. Clear, all of you? Yes. This is about oxidation states. Next one, hydrides. Hydrides. MH type hydrides or XH type. You can write XH. M, if you write M, that would become metal. So XH or HX type hydrides. HX type hydrides would be formed. HF, HCl, HBr, HI. These are the hydrides formed from which one? Halogen family. Okay. Hydrogen fluoride, hydrogen chloride, hydrogen bromide, and hydrogen iodide. So down the group, ionic nature of hydrides would be decreases. This is what ionic nature. Ionic nature down the group, ionic nature decreases. Okay, dear students, if possible, you just write along with me, because this is revision a little bit. I mean, there is no time to give to write. Okay, yes, that's what you just write along with me. Okay, next one, HF less than, HCl less than, HBr less than, HI. This is what? Anyone of you can guess? Acidic strength or acidic nature. Acidic nature. This is what? Acidic nature. Melting and boiling points. If you check melting points, HI has more melting point than HF. HF has more melting point than HBr. Then after HCl. HCl is the less melting point. And then after boiling points, if you check, HF has more boiling point than HI. HI has more boiling point than HBr, and here also HCl is the least boiling point. Least boiling point. Why HF is more boiling point? In HF, hydrogen bonding is present. That is the reason HF has a more boiling point. And also pKa values increases. pKa values, if you check pKa values, HF less than, HI less than, HBr less than HI. This is what, my dears? pKa values. pKa values. Okay. This is about hydrides. And then after oxides. Let me tell about oxides. Oxides, multiple oxides are formed by halogen atoms. So if you go to fluorine, O2, F2 and OF2. These two oxides only formed by fluorine. O2, F2 used for the separation of plutonium from spent nuclear reactors. O2, F2 is used to separate plutonium from spent nuclear reactors in the form of PuF6. Plutonium separated from the spent nuclear reactors. Spent nuclear reactors. Okay. And OF2 is thermally stable at 298 Kelvin temperature. 298 Kelvin temperature. OF2 is stable at 298 Kelvin temperature. These oxides, which we are going to call them as oxygen fluorides, because fluorine has a high electronegativity. And the next one is chlorine oxides. If you check chlorine oxides, Cl2O, Cl2O, Cl2O6, and then after Cl2O7. These are the oxides of chlorine. These are also highly oxidizing nature. And also after that, they are having highly explosive nature also. Among all these chlorine oxides, ClO2 is going to separate which one? ClO2 used as a bleaching agent, and also bleaching agent in paper pulp industry and also cloth industry, and also cloth industry nothing but garments. Okay. Next one is water treatment. ClO2 used as a bleaching agent I mean paper pulp, and then after garments and garment industry, and also water treatment. Okay, this is the bleaching agent. Yes, my dears. Next one is Br2O, BrO2, and PrO3. These are what? Bromine oxides. Bromine oxides are also highly oxidizing, acting as highly oxidizing agents, and also stored at room temperature only. That nothing but they can able to stable at RT, room temperature, not row transport. Okay, it is RT, room temperature. Okay, yes, stable at room temperature, and also these are also acting as good oxidizing agents. Okay, next one, iodine oxides. I2O4, I2O5, I2O7. These are also good oxidizing agents, and also these are solid oxides. These are what? Solid oxides. They are going to be dissociate under heating only. They are going to be dissociate under heating only. Okay. Next one, here in I2O, I mean all iodine oxides, I2O5 is used to separate. I2O5 is used to not separate, estimate the amount of I2O5 is used to identify or estimate the amount of CO estimation. CO estimation. I2O5 is used to estimate the amount of carbon monoxide. This is about oxides, and also last one thing is in oxides. Iodine oxides are more stable than chlorine oxides. Chlorine oxides are more stable than bromine oxides. After that, fluorine. These are bromine are highly unstable oxides, and also yes. Okay. Yes, this is about oxides, and the next one is hmm. I'm going to next page because it is less space. In next page, you can check about their oxy acids. Oxy acids. In oxy acids, especially HOF, only fluorine can form this one only. Only fluorine can form HOF. If you go to chlorine, HOCl, HOClO. This is chlorous acid. The previous one is hypochlorous acid. This is what hypochlorous acid. HOCl is what hypochlorous acid. HOClO is the chlorous acid. Next one, HOClO2 is the chloric acid. Next one, HOClO3 is the perchloric acid. HOF is what? Hypofluorous acid. HOCl is what? Hypochlorous acid. HOClO is what? Chlorous acid. And the HOClO2 is what? Chloric acid. And HOClO3 is what? Perchloric acid. Okay, next bromine, if you check, HOBr. Okay, hypobromous acid. Next here, bromous acid is not there, but bromic acid is there. HOBrO2 is there. And the next one is HOBrO3 also there. And if you go to iodine, HOI, hypoiodous acid. Here also iodous acid is not there. And HOIO2 is there. Okay, iodic acid, and then HOIO3 is there. Okay, per iodic acid. These are about oxy acids. And then interhalogen compounds. If you check, dear students, the meeting will going to be end within 5 minutes. Okay. Next one, interhalogen compounds. Interhalogen compounds. Interhalogens I am writing simply, okay? Next, interhalogens are X dash 1. Next, X dash 3. X dash 5. X dash 7. These are the interhalogen compounds formed by halogens, and X is what here? Higher halogen. Higher halogen. And X dash is what? Lower halogen. Lower halogen. Clear all of you? Yes. Next one. Fluorine F2 is the most oxidizing nature. F2 is having most oxidizing nature. Most oxidizing nature. Fluorine oxidizes water into oxygen. Fluorine oxidizes water into oxygen. 4F minus, 4H plus, and O2 gas. Clear all of you? Yes. Next one. X2. Reacting with water, then it will gives you HX and HOX. HOX. Next one, here X2 nothing but Cl2 or maybe Br2, remember, okay? Next one, iodine, nothing but elemental state iodine is going to be oxidized. Elemental state iodine is going to be oxidized. Here you can take 4H plus and O2 gives rise to 2 moles of I2 and 2 moles of water. Okay. Yes. Here iodine is going to be oxidized. In the first reaction, fluorine oxidizes the water into oxygen. And also halogens, if you check halogens, I mean metal halogens, M X type metal halogens are going to be formed MF, MCl, MBr, MI. Okay. Next, SB, SBCl6. Next, CL6 is not SBCl5 తీసుకోండి. SnCl4, PbCl4. Okay. UF6. These are all covalent nature. Okay. These are all covalent nature. Next, SbCl3, SnCl3, SnCl2. It is not 3. And PbCl2, UF4. When compared to covalent nature between last one, middle one are having more covalent nature. Okay. Yes. You can take screenshot.